In today's class, we are going to see the construction working of ultrasonic flow meter. So, generally there are two types of ultrasonic flow meters. One is time difference type, also called as transit type. The second one is Doppler flow meter. So, this time difference type or transit type flow meter uses acoustic signals transmission pulses, and this Doppler flow meter uses continuous signals. So, here we are going to see the time difference type or the transit type ultrasonic flow meter. So, here the basic principle is the transmission of sound waves to a pressurized liquid in a pipe is the basic principle of this ultrasonic flow meter. So, this ultrasonic flow meter is used to measure the flow rate of the liquid by passing the sound waves through that liquid. So, the basic principle is the transmission of sound waves through a pressure liquid in a pipe. So, by passing the sound waves, we can measure the flow rate of that liquid. So, the transit type or time difference type ultrasonic flow meter is used to measure the flow rate. So, generally this transit type flow meter has two piezoelectric crystals. Placed inside the liquid or gas, which is separated by a distance. So, here in these two piezoelectric crystals, one crystal acts as a transmitter and the second crystal acts as a receiver. So, the transducer or the piezoelectric transducer is used in which one acts as a transmitter and another acts as a receiver. So, the ultrasonic transit type flow meter sends and receives the ultrasonic waves between these two transducers, that is between these two crystals in the both up and downstream of the pipe. So, the transmitter emits this ultrasonic pulses which is received at the receiver at the time difference is noted, which is used to measure the flow rate. Okay. So, here the ultrasonic flow meter sends and receives the ultrasonic waves between the transducers in both upstream and downstream directions. So, transit type flow meter, we are having a pipe where the liquid flows inside the pipe. The velocity of the liquid flow is taken as V. So, here the transducers, that is piezoelectric crystals which acts as transducers, is placed inside the liquid and is placed at a distance d between them, so that one transducer acts as a receiver. These are the piezoelectric crystals which acts as the transducers. So, here one crystal acts as the transmitter and other crystal acts as the receiver. So, either this transducers or the crystals may be placed inside the pipe where the liquid flows, whose flow rate is to be measured, or it can be placed outside or the both ends of the pipe where the liquid flows. So, this ultrasonic flow meter sends and receives signals between these two transducers. So, when this signals passes between this transducer based on the flow of the liquid, this signal is detected based on the time which takes the sound to pass through. Okay. So, here the transmitter emits an ultrasonic pulse which is received at a time del t later. So the ultrasonic pulse produced by the transmitter is passed into the liquid which is received by the receiver after a time del t. So the transit time in the direction of flow is taken as del t1, which is equal to d divided by c plus v, where d is the distance between this transmitter and the receiver, c is the velocity of the sound wave propagation in this medium, that is the liquid, and v is the velocity of the flow. So d is the distance between the transducers which acts as a transmitter and receiver, and c is the velocity of sound propagation in medium, and v is the velocity of flow. So the transit time in the direction of flow is calculated as del t1 is equal to d divided by c by v. So if we consider when the signal is transmitted in the opposite direction, that is from the receiver to the transmitter, that is against the fluid flow, the transit time will be, that is we are considering when the signal is travelling in the opposite direction of flow. The opposite direction of flow, the transmit time is taken as del t2 is equal to d divided by c minus v. Similarly, a signal of frequency f hertz travelling in the flow direction has a phase shift of del phi 1 is equal to 2 pi f d divided by c plus v, and the travelling time against the direction of flow has a phase shift of del phi 2 is equal to 2 pi f d divided by c minus v radian. Therefore, the velocity can be determined either by measuring the transit time del t1 and del t2, or the phase shift del phi 1 and del phi 2 in the direction of flow and against the flow. Now let us consider the ultrasonic flow meter, in which the transducers are placed on the pipe which carries the liquid whose flow is to be measured. So here the transducer, these are the transducers. So here one transducer acts as a transmitter and another transducer acts as a receiver, and the distance between the transducers is taken as d, and the transducers are connected to an electronic oscillator and a detector. This electronic oscillator and detector are connected with the help of a commutating switch. So one transducer acts as a transmitter and another transducer acts as a receiver. So here the electronic oscillator produces a sinusoidal signal of about 100 kHz frequency to the crystal, that is which acts as a transducer, that is transmitter transducer, and it receiver receives the signal which is transmitted by this transmitter, which is placed as a distance d between them. Those a function of transmitter and receiver are reversed periodically with the help of this commutating switch. So initially if this transducer acts as a transmitter, it will receive the signal. If it acts as a transmitter, it will receive the signal. Both the signal will be passed to these two transducers. So here at no flow conditions, it takes same time to travel upstream and downstream between the transducers. So at no flow conditions, that is when there is no flow, the time taken for the signals to travel upstream and downstream is equal. When there is a flow, that is under flowing condition, the upstream wave will travel slower and take more time than the faster downstream wave. So under flowing condition, the upstream wave will take time to travel and the time taken is more compared to the wave which is moves over the downstream, or the time taken to move the downstream. That is, the signal is delayed with the movement of this moving fluid. This moving fluid makes the signal to gets delayed to reach the transmitter on the receiver under flowing conditions. So when the fluid flows faster, the difference between the upstream and downstream time increases linearly. So the difference in transit time del t is given by del t2 minus del t1, that is 2 dV divided by c square minus v square. So the difference in transit time is measured with the help of this phase sensitive detector, which is driven synchronously with the help of this commutating switches. Generally the value of C will be very large compared to V. So the equation becomes, generally the value of C is greater than V. So the transit time is taken as del t is equal to 2 dV divided by C square. Here the V is neglected. So the transit time, now the difference in transit time for the sound waves to travel in both upstream and downstream conditions taken as del t equal to 2 dV by C square. So from this we can see that the del t increases proportionally and linearly with velocity V. But the value of C is uncertain. So this uncertainty in the value of C leads to error in this type of meters. So the del t increases linearly with velocity here, which leads to an error because of the uncertainty in the value of C. So this problem is solved by another system which is developed based on the frequency. Now let us consider system based on frequency. So a system based on frequency was developed. So it has two transducers. This one acts as a transmitter and another acts as a receiver. Similarly, receiver and the transmitter. And the receiver and transmitter will be connected with the help of a amplifier, and this is given back to the transmitter as a feedback. So a feedback system is used here in order to reduce the here, that is the liquid flows like this. The velocity of liquid is taken as v. When the signal passes from transmitter to the receiver, here the signal flows from the transmitter to the receiver, and the angle between this liquid flow and these transmitter waves is taken as theta. So it shows two self-exciting oscillating systems. Why it is self-exciting is, so the received pulse is used to trigger the transmitted pulse. The received pulse is measured, amplified and used to trigger the transmitting pulse. So it is a self-exciting oscillating system. So the pulse propagation frequency in the forward and the reverse loop is taken as 1 by del T1, and for the backward loop is taken as 1 by del T2. So the transit time del T1 is given by d divided by c plus p cos theta, and del T2 is given as d divided by c minus v cos theta, where d is the distance between these two transducers. Similarly, from this time the frequency can be written as f is equal to c plus v cos theta divided by d, f2 is equal to c minus v cos theta divided by d. So if you find the difference in frequency, del f, which is equal to f1 minus f2, so we will get 2v cos theta divided by d. So the output is independent of the value c in this case, where a feedback system is used. So the error created because of the value of c is not taken into account here. So output voltage is independent of the value of c. So output, but also the output is linearly proportional to the velocity v, that is transit time and the frequency is directly proportional to the flow velocity v. Now let us see the advantages of ultrasonic flow meter. Here no obstruction to the flow, so can be applied to sanitary, corrosive and abrasive liquids. So it can be used for the flow measurement of sanitary, corrosive and abrasive liquids, as there is no obstruction to the flow, and they are also not affected by variations in characteristics of the liquids like viscosity, density and temperature. And also there is no moving parts in the instrument, and also we get linear relationship between input and output. And also it can be used for bidirectional flow. So these are the various advantages of ultrasonic flow meter. And the disadvantages is it has high complexity and the cost is also high. The applications, this ultrasonic flow meters can also be used to measure the velocity of liquids, that allows ultrasonic waves to pass through such as water, molten sulfur, cryogenic liquids and chemicals. So it can be used to measure the velocity of any liquids that allows ultrasonic waves to pass through, and it is also used for gas and vapor flow measurement. Can be also used to measure gas and vapor flow measurement. Thank you.